we look at a circle, you have the center of a circle, okay? And the center of the circle is how you name a circle. So like this circle right here, it would be called circle T, or sometimes you'll see this symbol for a circle where it just has a circle with a dot in the middle of it, circle T. Okay? And then of course you have the interior of the circle, inside the circle, the exterior. These are the points on the circle right here. And then you guys have done circumference before. So circumference is just circumference is the measure of the outside, right? And that's what mostly we're going to be talking about today, is just the circumference, the outside. And then we are talking a lot about arcs today. So the arc is just an unbroken piece of the circle. So, for example, from A to B, that would be an arc. It's that piece, that blue piece right there. Or that yellow piece would be an arc. And when you talk about circles and arcs, there are three different kinds. There are going to be minor arcs. Minor arcs, which is less than half the circle, okay? And when you're talking about the measure of arcs, you're not talking about the length, but the measure. You're talking about how many degrees. So the whole circle is 360 degrees, and a minor arc is less than half of a circle, and is less than 180 degrees. And a semicircle, you guys have heard semicircles before, right? It's a half a circle, so it's 180 degrees. And then major arcs are more than 180 degrees, so more than half the circle. And so when you name them, in order to name, like this one I did right here, arc AB, when you name minor arcs, you only need 2 points. So when you see 2 points, you know for sure it's a minor arc. Because from A to B just means from this A to this B. But if I name like CAB, would be from C to A to B, and so you got to go in the right order. C to A to B would be that blue arc right here. This one would be. And you name major arcs by 3 points, so you know which way you're rotating around the circle. And you could, like I could name a minor arc by more than 2 points. If I wanted to say that this was point D, I could call this arc right here that goes from C to B, that could be arc CB, CB with an arc over it. Or, you know, there's nothing wrong with naming it CDB. You could name it with more than one, but for sure, if it has 2, you know it's less than half. Yeah. Arc AC would be from A and C would be the endpoints of arc AC. So you look at this. Arc AC could be 2 different things. It could either be going this way, or it could be going this way, because it's a semicircle. So that's why on a semicircle you have to include another letter so you know which part you're doing. So ABC. If there were no B, then you wouldn't really be able to name it. If it's asking you to name it, it would probably have a point there for you to name it. So like this one, ABC is that semicircle. And if I wanted to name the other semicircle, we'd probably need another point on there so that we could name it by something else. I'll put D as something else instead of that one. Okay. So central angles have the vertex at the center. And so if I tell you the central angle, then you could tell me the measure of the arc. So right here, if I said this one was 30 degrees was this angle right here, then you would know that this arc right here is 30 degrees. So the measure of the central angle and the arc are the same. So it's not the length of them, it's like how much of 360 it is. Okay? So like right here, if these are vertical angles right here, then what would this angle right here be? Angle FAB. 30 degrees. And so this would be 30 degrees. Okay? And I'd have to probably give you more than that. actually, if this is 30, I could find this angle right here, right? BAC. What's the measure of that angle? Because this is a straight line right here. 150 because they add 180. And then this one's a straight line. Wait, does this one go over? Yeah, that one's not straight right there. So that one's 30. This whole thing would be 150, right? This piece right here. If I ignored this line right here, 30, 30, 150, 150. But if I told you this one was 120, then you could tell me, I don't like that number. If I told you this one was 130, then you could find this little one right here, couldn't you? 20, because I'd have to add to 150, or the whole thing has to add to 180. And so then from there, if I asked you any measures, you could find them also. So if I said find the measure of arc CE. Is CE a major arc or a minor arc? Can you guys see where CE is? It has to be less than halfway, so it has to be that one. What would the measure of that one be?
50.
Yeah, 30 plus 20, 50. So that's kind of some of the things you're going to have to do. Yeah, it's going to be super easy. This part for sure.
It's going to get hard.
No, it doesn't get too hard. This is way easier than what we've been doing. You guys will love it. So minor arcs. Marcus, tell me one minor arc.
C to D.
Which one?
C to D.
C to D, okay. And a major arc. Nicole, tell me a major arc. So it has to have 3 points and be more than halfway. E, B, C. Can you guys see that one? E, B, C. All the way to there. Do that one. And then semicircles. Ethan, tell me a semicircle. D, C, B. Okay. So semicircles have. So let's look at it. This one is a straight line. So this is one thing you know. This is a straight line. So if this is 90. Yeah, this other angle is 90. That's 114. So they have to add to 180.
That doesn't look like a straight line.
This one does. This one isn't. What is it?
Probably just
626.
sideways.
And then if I asked you any measure of the arcs, like this would be 90, 90, 66, 114, and then any other ones you could just add them up, right? Or if I asked you for the arc, the measure of the arc SVT. So SVT. You could add up the other ones. You could add up these pieces right here. Or you could just make it faster if you wanted. Just do 360 minus 66. Right? Instead of adding them up. Either way, it doesn't matter. Now this one's a little bit trickier. So this is kind of not labeled very good. This right here is from S to R, and that many degrees. This one's the measure of this angle is X plus 45 degrees. This one's 112, and then you have to find this measure and find out what X is first. So, thing to remember, if this is X plus 45, this is X plus 45, right? Everything's going to add to 360, and you just got to figure out what everything is and make an equation. So if this is 112, do I know what this arc is right here? 68, because they add to 180, right?
Oh, yeah.
Straight line right here. And if that one's 68, then what's this one?
68.
68. So now you can find out what X is by doing 68, 68, 112. X plus 73, X plus 45, is that it? Equals 360. Solve that. Yeah, if you notice that this is 112, oh, undo that. This is what's left is 112 right there. Oh yeah, because it was like right here, huh? Vertical angles. So you could just do, someone solve that for me while I'm writing it. X plus 45 equals 112. And I could get that same thing too if I subtracted those to the other side, I'd get 112. So negative 6, x equals negative 3. And so now if you want to find the measure from s to q to t, so I got to make sure I go s to q to t, so I guess I got to go towards q first, and then t. Well, if I ask for x, I would need that. Actually, from s to q to t, I really don't even need to do all that, right? If that were the question. I mean, if I need to find something else, I would have to find x. But if I need to find this, then I could just do 360 minus 68 and found it that way. If that was the question. So realize how to solve for x if you need it. So that if you needed to find a shorter piece, you could find that. But yeah. So circumference and arc length are talking about distance rather than the measure out of 360. So we have both of those. Do you guys remember this formula? Should. I know they're doing it in 7th grade, probably earlier. 2 pi r, or pi times the diameter. And just remember, on a circle, that you have halfway across is the radius, and all the way across is the diameter, yeah. Okay. So on this one, it depends on how it asks you to find it. You either need to do it in exact terms, means you leave it with a pi. So if I do 2 pi r, sorry, I'll do 2 r pi. 2 pi r, this would just be 9 pi feet. So this would be the exact answer in terms of pi. And then the rounded answer would just be plug in 9 pi into your calculator. So it depends on if it says exact, and you need this. Rounded, type in 9 pi. If you do this, look at it, 28.274. See if it makes sense. If that's for, yeah, I mean, if you get something like 600, you know you're way off. Okay, the only the hardest thing about today is doing arc length. So when you do arc length, you need to consider how much of a circle it is. So on this one, you find the circumference. So see what you can figure out. I only want to know however you can figure it out, and you guys can tell me which ways you figure that out. I want to know arc AB, the length of it. So how long is it? Not the measure, but the measure of arc AB is 60 degrees. It's 60 out of 360. This radius is 15. See if you can find me the length of AB. So let's look at this. So you guys decided that it was 60 out of 360. It is 1/6 of a circle. Right? The ratio of the 60 degrees over 360, it's 1/6 of a circle. So you take your answer and divide it by 6. So you could do it like that. That's one way you can do it. Just do 1/6 and then you times it by the circumference. So you have 5 pi or 15.7 meters. Okay? That's probably the easiest way, is to just come up with a fraction, what fraction of a circle it is, and then times it by the circumference. So that's kind of weird, but look at this one. If I'm doing this one right here, how much of a circle is 5 pi over 6?
That's the solid.
It's 5/12.
150%. I mean, not percent.
Okay, so you could think this is 150 degrees, right? And you were thinking it is
5/12.
5/12. It is 150 over 360. Does someone reduce that? Does it equal 5/12?
15 over 36.
Yeah, it is 5/12 of a circle. So watch what happens with this though. This is kind of nice. If you notice this pattern, I'm going to do 5/12 times the circumference. What's the circumference? 2 pi r I'm gonna do 6 pi times 5/12. So 30 pi over 12, whoops, pretend like that's a 5. What is 30 over 12 reduced to? 15 over 6, no, yeah, more. Divide by 6, 5 pi over 2. 5 pi over 2, so but watch this, watch what happens with this. If you have this in radians, look how easy this, we thought it was going to be harder, but look what this is. If I just times those two together, look what I get. 15 pi over 6, divide by 5, or sorry, divide by 3, 5 pi over 2. It actually, that is actually one of the formulas. If you know the radius and you know the radians, because the radians have to do with the circumference of the circle, if you just times those two, you get it. Which, you can do this still. I mean, this worked if you forgot. But if you know the radians, and you know this, times them.
Where'd you get the 15 pi over 6?
That's 3 times 5.
Like there. Times it across, times it across.
Oh, okay, yeah.
So this is actually a cool formula. If you have the radius times the angle, if this is in radians, this is the arc length.